my name is Diego Caldera, and I am doing my physics over my golden wheel spider. So over here, here's my free body diagram. We're going to be looking for the force today, and while I have my down force, which is my gravity, which I multiplied by my mass of my mimic, and it came out to 0.981. So over here, I had to start off by looking for my K constant. So to look for that, I had to find a random object and measure it by stretching out an elastic rubber band that I used. So I found the mass of the object, which ended up being a 9-volt battery, which was about 45 grams, so I converted that over to kilograms. I also just used basic gravity, and then the displacement at the end, which ended up being 15 centimeters, which came out to 0.015 meters. So after doing all the equations, I ended up coming out to finding the answer being 29.43 Newton meters. So to find my potential energy, of course, I need my K constant. So now that I have my K constant, I can go look for this potential energy. So in this case, I ended up using the elastic potential energy, where my K now is my spring constant, while my E is still my elastic extension. So I plugged in those numbers from here, so my K constant down here, and my elasticity displacement from down here. And after doing those calculations, I ended up finding out that my potential energy came out to be 0.0033 newtons. So now I got my potential energy down, I can look for my velocity. So by looking for my velocity, I can plug in the kinetic energy equation. So by doing that, I can assume that my potential energy equals my kinetic energy due to energy balance. So I'll plug in my numbers into the equation and isolate for my velocity. So after doing that and making my calculations, I found out my velocity equals out to 0.216 meters per second. Alright, so now that I have everything, I can look for my thrust force. So I'll be looking at both the final minus the initial of both my mass and my velocity versus my time. So I plugged in everything to find out that my final force would equal out to be 0.0216 newtons.